Hello, my dear children. Children, in the class of optics, we are going to study heart and soul of ray optics. So, what are these heart and soul of ray optics? Let us know. Well, the very first thing of the day is Snell's law of refraction. Refraction, we know, is passage of light from one medium to another. So, as light moves from one medium to another, well, the angle which incident ray makes with the normal at the point of incidence. This is boundary which divides two different media. This is medium 1, medium 2. This is incident ray. The angle which incident ray makes from normal at the point of incidence is angle of incidence. This is angle of refraction which refracted ray makes from the normal. Now, what is Snell's law of refraction? Snell's law of refraction, you already know, is nothing but ratio of sine of angle of incidence to sine of angle of refraction is constant. Ratio of sine of angle of incidence to sine of angle of refraction is constant. What is that constant? Well, that is very, very important. What is that constant? This constant is nothing but refractive index of medium 2 with respect to 1. This is medium 2 with respect to medium 1. This is also the ratio of absolute refractive index of medium 2 upon absolute refractive index of medium 1. And in terms of speed of lights in medium 1 and 2, this constant is speed in medium 1 to speed in medium 2. So, Snell's law of refraction says that ratio of sine of angle of incidence to sine of angle of refraction is constant. But what is more important at this stage is what? To know very thoroughly about this constant. This constant is read as refractive index of medium 2 with respect to medium 1. What is medium 2? Medium 2 is the medium of refracted ray and medium 1 is the medium of incident ray. So, this constant is refractive index of medium of refracted ray with respect to refractive index of medium of incident ray. And this is also the ratio of absolute refractive index of medium of refracted ray to absolute refractive index of medium of incident ray. And in terms of speed of lights in medium number 1 and 2, it is the constant is read as the ratio of speed in the medium of incident ray to the speed in the medium of refracted ray. Why it is different? Why it is this is mu2, this is mu1, this is C1, this is C2? It is simply because we have already studied refractive index of a medium is inversely proportional to speed of light in the medium. Absolute refractive index we know already, we have already studied. Absolute refractive index of a medium is the ratio of speed of light in free space to in the given medium. So, what is the constant in Snell's law? That is very, very important. And throughout ray optics, there is another law which is always followed is principle of reversibility. Principle of reversibility. That means all rays throughout ray optics, they are reversible. If this is incident ray, this is refracted ray, and if the light falls along this direction, this would be refracted ray. In that case, this is going to be angle of incidence, this is going to be angle of refraction, and this is going to be medium of incident ray, this is going to be the medium of refracted ray. So, if the light moves from this side to this side, well, all these 1 and 2 will change. Just one thing you have to remember, sin I upon sin R is a constant, and that constant is refractive index of medium of refracted ray to the refractive index of medium of incident ray. And in terms of speed, it is ratio of speed in medium number 1, that is medium of incident ray, to medium 2, that is medium of refracted ray. So, that was Snell's law of refraction. Well, the second most important thing of ray optics is sign convention. Children, in ray optics we come across various type of distances like object distance, image distance, radius of curvature, focal length. So what are the sign of these distances in various situations? That is what we are going to discuss. The rule to decide the sign of object distance, image distance, radius of curvature, focal length of lens as well as mirror. There is a rule. There is a rule to decide the sign of these distances, and that rule is called as sign convention. Children always struggle to apply this sign convention, but it is very, very simple. I am just going to write a sentence. You have to understand it and apply it right now. So what is sign convention? Say, all distances measured from optical center, that is also called as pole. So all distances measured from optical center in the direction of incident ray, are positive. Yeah, this is sign convention. So what is important about this particular sentence? There are three things which are coming up from this sentence. Let us understand this. All distance measured from optical center in the direction of incident ray, are positive. So the very first thing which is coming up is we are going to measure all the distances from optical center. What is optical center? Optical center is nothing but center of the optical surface or optical device. There is a technical definition of optical center also, but just remember a simple thing. Optical center is the center of optical surface or optical device. That is optical center. We also call it as pole, like center of the mirror, center of thin lens. So just remember, all distances are measured from optical center. This is the first thing which is coming up. Number two, if the distance are measured in the direction of incident ray, they are positive. The second thing which is coming up is, when are distances positive? All distances are measured from optical center, but if the distance is measured in the direction of incident ray, means parallel to incident ray. So if distances are measured from optical center in the direction of incident ray or parallel to incident ray, those distances are going to be positive. And if we are measuring any distance in the direction opposite of incident ray, then that distance would be a what? Negative sign. If distances measured in the direction of incident ray are positive, then distances measured in the direction opposite of incident ray are going to be negative. Now the question arises, what is the direction of incident ray? Direction of incident ray depends upon where we have placed the object. If the optical device is, say, this is your optical device, and we place the object where? Say left. This is object. This is real object placed left side of this optical device. So what is incident ray? Incident ray is going to be from left to right. This is going to be direction of incident ray. If we place, this is another optical device, say. If we place an object, say here, what is direction of incident ray? Direction of incident ray would be from right to left. See, what is direction of incident ray? It depends upon the position where we place object. If this is an optical device, say mirror, this is concave mirror. If we place an object here, what is direction of incident ray? Direction of incident ray is from, in this direction, from object towards the optical device. From, say, top to bottom, in this direction. And if we place an optical device like this, say, yeah, this is an optical device and the object is placed here. Well, in this case, the incident ray is going to be like this. So what is direction of incident ray? It all depends upon where we have placed the object. If the object is placed left of the optical device or surface, the incident will be from left to right. If the object is placed below the optical surface or device, the incident ray would be what? Like this. And if the object is placed above, the incident ray would be from above to below. If the object is placed right, the incident ray would be from right to left. So what is direction of incident ray? It depends upon where we have placed the object. Now, if the distance traveled is in the direction of incident ray, it is going to be positive. And if the distance is measured by moving in the direction opposite of incident ray, that distance is going to be a negative sign. Now, all distances are measured from optical center. What is optical center? Optical center is simply center of the optical device. Yeah, this is optical center or pole. 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 So in this situation, see, when the object is placed towards left, remember all distances are going to be measured from optical center, and the distance is in the direction of incident ray, it will bear positive sign. And if the distance is in the direction opposite of incident ray, any distance measured in this direction would always bear what? Negative sign. Since the object is placed this side, therefore incident ray is from right to left. So the distance in this direction would bear what? Positive sign, and distances in this direction would bear what? Negative sign. Like here, the object is placed here. What is the direction of incident ray? Yeah, this is the direction of incident ray. So distances which are going to be measured in this direction, they would be positive, because they would be in the direction of incident ray, and the distance which are going to be measured in this direction, they would be distance measured in the direction opposite of incident ray, their sign would be negative. Here also, in this case, since incident ray is like this, therefore in this direction the distance would be positive, and in this direction the distance would be what? Negative. So this is sign convention, very very simple. All distance measured in the direction of incident ray from optical center are positive. Children, let's know what is optical path. We all know that the light has different speed in different media. So even in the same time, light is going to cover different distances in different media. So how to compare these distances? If the distance traveled by light in different media, they are to be added or subtracted from each other. Well, at face value we cannot add or subtract them. What do? We convert them in their optical path. So what is optical path of a distance? Optical path of a distance is nothing but the corresponding distance traveled by the light in vacuum. If light travels certain distance in given medium in any time, then in the same time whatever distance it is going to travel in the vacuum is going to be its optical path. The corresponding distance traveled by the light in vacuum in the same time is called its optical path. The optical path is corresponding distance in free space or vacuum in same time. Suppose light travels distance delta. Delta is what? Distance in vacuum or free space in time t. Then what distance it is going to travel in the medium where refractive index is what? N. The distance it is going to travel in the free space is delta in time t. Then what distance the light is going to travel in the vacuum? That distance d, the corresponding distance d, the optical path of this distance d is nothing but delta upon n. What is this delta? Delta, you know. What is n? N is refractive index of medium. Or we can say delta is equal to what? Delta is equal to ND. Delta is equal to ND. This simply means if light travels a distance d in the medium whose refractive index is n in any time, then in the same time it is going to travel a distance nd in free space. This nd is optical path. Optical path of d. So if light travels a distance d in the medium whose refractive index is n in any time, then it is going to travel, the light is going to travel nd distance in free space in the same time. So this delta is optical path of distance d which is traveled in the medium whose refractive index is n. So delta is corresponding distance of d in vacuum in the same time. There is a small, very small workout as far as this relation is concerned. See, delta is the distance travelled by light in vacuum. What is speed in vacuum? Say speed in vacuum is c0 and the time taken to cover distance is what? T. So what is this delta? Delta is going to be c0 into t. Distance is going to be speed into time. If light travels certain distance in time t in vacuum, then that distance is going to be what? Speed into time, delta. Now if light travels a distance d in the medium where refractive index is n, then this distance d is going to be what? This distance d is going to be speed in the medium into time t. Distance is speed into time. This is distance in medium where refractive index has say value n. So this d is going to be speed in the medium into time t. Let us divide the two. If we divide delta with d, what do we get? We get c0 upon cm. This t cancels out. And what is speed in vacuum to speed in the medium? Speed of light in vacuum to speed of light in the medium is nothing but refractive index of the medium. Absolute refractive index of the medium. So what is this? What is this? Yeah, delta by d is equal to n. And that is what we have written as what? Delta is equal to nd. So delta is equal to nd is optical path of distance d in free space. So with this we come to the end of today's class. Thank you very much and God bless you.